green hydrogen, decarbonization of cement, steel, aluminium, and ammonia production. As India moves steadily towards meeting its climate goals, there's growing pressure on industries to decarbonize. Green hydrogen, with its zero emissions profile, has emerged as a promising pathway for decarbonization, with the potential to create a more sustainable future for Indian and global industries. To deliberate on this theme, let's hear from the thought leaders and the innovators in our next panel. Inviting on stage our panelists, Dr. Jatin Agarwal, Program Director, Tridiagonal Solutions, Mr. Shaji John, Senior VP, Sales and BD for South Asia, Middle East and Africa, and Global Head of EPC and Project Development, Omnium, Dr. Pavan Mendiratta, Strategic Business Unit Head, Green Hydrogen and Derivatives, Thermax, Mr. Anand Vasappanavara, Director of EH Group. And the session will be moderated by Professor Arvind Kumar Chandiran, IIT Madras.
Thanks so much for the opportunity again. I think it's great to be in the Envision. And so right after this extremely high-powered solar session, we have this hydrogen session. And I think there are a lot of discussions about technology from academia to lab and so. And in hydrogen, I think we're going to talk a very similar thing, the real world problems. I think that's what we will be having today. I'm going to slightly twist this chair a bit so that I can see all my panelists. So just a quick round of introduction to our extreme panelists here. First of all, thanks everyone for being here today. And this is one of the kind of fantastic combinations of panel members we could imagine. Let me start with Sri Pavan Mendiratta, who is sitting in the middle. So he is the head of the green hydrogen business at Thermax, and if you look at his profile, so it is really excellent, like covering like variety of fields in the hydrogen segment, starting from gas turbines to electrolyzers, and eventually electrolyzers of course produce hydrogen. And he was also a CEO of L&T businesses in the energy sector, and he was also with GE in the past. So welcome Pavan sir today for this discussion. Now, so on one side we have an experienced, fantastic person on the hydrogen. On to my left we have Dr. Jatin Agarwal, and he is the person who helped all the academic innovations to translate into the industrial business. So essentially, typically academics develop products maximum up to TRL4, and Jatin in his business are Tridiagonal. So they translate the technology from TRL4 to TRL7 or 8, which eventually can be taken up by the larger industries. So welcome Jatin to this panel discussion. And we will, I'm sure most of you are very familiar with Shaji John sir here from Omnium. So he is a man who is behind a lot of successful solar energy initiatives at L&T in the past, and now he is at Omnium as a senior vice president and leading a lot of electrolyzer initiatives. Welcome, Shaji sir. So we're going to really expecting a lot of fire discussions on solar plus hydrogen generation thing. And so all this, like three people, I mean like mostly on the generation side, of course Jatin can do on the utilization side as well. We have an exciting technocrat, Anand from EH Group. So on to the extreme left, to my extreme left. So he is from EH Fuel Cells. And he is the man, I mean, I would recommend you to really spend time with him if you're really a technocrat. I mean, you just talk about fuel cells, he give you the complete details. The person who is always really happy to discuss a lot of technical details. And Anand, I'm excited to have you in this panel today. Great. With that introduction, I think I'm going to start, like not more introductions now, but then I'd just like to go into the technical things. The green hydrogen has been kind of widely talked about. I've been sitting in a lot of panel discussions in the last 1.5 to 2 years, and we talk about many generic things, and today it's not going to be a generic thing. If we want to learn about basics of green hydrogen, too many things in the internet, let's find it out. But now we're going to focus on more important things. I'm going to ask very pointed questions to our panelists. With their experience, they're going to really enlighten us with the answers for those questions. So there'll be 2 rounds of questions, like where our panelists will be answering for a maximum of 5 minutes each, and that's how the structure is. And finally, there'll be concluding remarks from them, of course, with some questions being taken from the audience, if time permits. Right. Now, let me start with our first expert who's sitting in the middle, Pavan sir. Sir, on the green hydrogen segment, there are a lot of talks about converting all the gray hydrogen, which we are like producing 6 million metric tons today, to green over time. And by 2030, our ambitions are around 5 million metric tons to be completely in the green, right? Green segment. Essentially, if that has to be produced, the only option we have is go to electrolyzers powered by renewables, right? But then I've also looked at the other side. The Indian government projected somewhere around, for this 5 million metric tons of hydrogen production, we would need around 25 gigawatt of electrolyzer production, right? Electrolyzer installation, like operating capacity in the country by 2030. Question is, are we ready to have 25 gigawatt either by local manufacturing or by importing? And I feel like somewhere I think there is a big gap between ambition and then there is a reality. And could you please enlighten us on that?
Thank you, Professor Arvind, for having me here. First of all, it's great to be here at Envision and be part of these good discussions today on various aspects. So coming to your question, you know, recently there was a PLI for the electrolyzers manufacturing for 1.5 gigawatt. And that was actually oversubscribed. I think about 2 or 2.2 gigawatt has been tendered out. And if you consider that there is about 1.5 gigawatt per year also, you know, and in the next 5 years, you can easily reach about 7 to 10 gigawatts of installed capacities. But then there are companies in India now who are planning to set up even 2 or 3 gigawatts of electrolyzer manufacturing. You know, I was at L&T prior to my current role at Thermax, where I kind of led the initiative for L&T to set up a 1 gigawatt manufacturing unit for alkaline electrolyzers, which as I understand is truly on the way, and it should be operational by middle of this year. So I think, and I was reading a report on BNEF, which was published last month, which projected that by 24, the worldwide electrolyzer manufacturing capacity would be close to about 55 gigawatts worldwide per year.
Just sorry for the interruption, but there are like on one side predictions really, whenever we read this document, we really got excited also, you know. I mean, there's too much on paper. But then imagine even if L&T is making 1 gigawatt electrolyzer, and then there are other companies which are also saying like, we'll produce electrolyzers. We expect all those things to be out in the market, let's say possibly in 2025. Still, it won't meet our 25 gigawatt requirement by 2030, right, sir?
Well, the 25 gigawatt requirement, you're right, has to be, is quite ambitious, and it has to be partly met by import of electrolyzers and by indigenized manufacturing of electrolyzers. But what I'm trying to say is that, you know, given the fact that, you know, India's manufacturing capabilities are very good, I don't think, I expect to see an installed electrolyzer manufacturing base of at least 5 to 7 gigawatts per annum within the next 2 years. So I think, and that will be a combination of various technologies. That will be alkaline, that will be PEM, that will be, you know, even the AEM or the solid oxide. So I am quite confident that in next 2 years, we should have a manufacturing capacity of close to about 5 gigawatt per annum. In fact, at Thermax itself now, we are looking we are strategizing and we are looking to set up a electrolyzer manufacturing capacity of at least half a gigawatt within, let's say, this year we want to start. So by next year, we should have half a gigawatt. So I'm quite confident that in the next 2 years' time, we should have at least about 5 gigawatt of manufacturing capacity in India. And second part, the 5 MMTPA target which the government has set is ambitious.
Okay.
It is definitely ambitious. And if you see, 1/3 of 5 MMTPA is expected to come from exports of ammonia, you know, and the rest is from the domestic consumption. It's quite ambitious. I do not think that I hope we meet that, but probably I estimate that we should be able to reach somewhere half of that capacity is what my estimate is, which would require about 10 to 15 gigawatts of electrolyzers. I think that should be about 70-80% met by indigenous electrolyzers and about 25% by imported electrolyzers.
Oh, that's really excellent to have a kind of optimistic view and more realistic view from you, sir. Really, thanks. Yeah, I mean, I would like to have a slightly connected question to Shaji, sir. Sir, you've been in renewable business and a lot of successful, solar initiatives at L&T. And on one side, the electrolyzer manufacturing, either it can be 25 gigawatt or as Pawan sir has mentioned, it can be somewhere around 10, 12 gigawatts also. But then we need to also think about 24/7 green electricity to those electrolyzers in order to really supposedly call green hydrogen, right? And of course, the banking time and all those things are like, I think it won't really last long. Eventually, it'll have to come down to shorter banking time or with energy storages. So how do we think we can achieve that green component to that hydrogen, like whole hydrogen segment? Since you're from this, from the electrolyzer company, I'm sure, and also had a phenomenal solar background. What are your visions and thoughts? I mean, either from the OMIUM side or in general, to like moving from gray suddenly to the green, without any banking, let's say. Let's not go into the banking business at all. How do you think it's possible? What is the reality?
Thank you. That's a great question and tough to answer, because the fact remains that it's not going to be easy to move from gray to green instantly, right? It has to go through its phase of movement. And also, when we are talking about green hydrogen, it will be tough to see that we provide 24/7 green power. And you are told that banking is not there. And fact remains that banking will not be able to support such huge amount of capacity addition. So there are two ways to look at it. Number one, beyond solar and wind, what could be the energy storage solutions? And obviously we all are talking about batteries as one option, but I don't say that it will fully solve the problem of storage. There are other options like pumped storage, which countries gearing up to, and big companies like Tata and NTPCs are all working on creating those pump storage. So that will be a combination which can take the CUF of green power from 25% of solar CUF or 35% of wind CUF. With this combination, you can reach up to around 75% of CUF. I don't think by 2030 period, you will have a solution for 24/7 green power. So you have to live with that problem that you cannot go beyond 60-70% of CUF, which means that for the rest of the 30% time, the capacity will not be utilized. The plant will be idle. So that the economics we have to work out. So this is option one.
Okay. Sir, if I may interrupt, so during that time, do you think that we still can use the, like, let's say, grid power, and then eventually use that, or you have to keep the electrolyzers idle during those time when you don't have renewables?
Technically, you can use, but the definition of green hydrogen will get questioned, right? Because all the regulators across the globe have given a clear definition of what is the meaning of a green hydrogen. And in that, grid-based power is not allowed. It has to be correlated with real solar or wind or pumped hydro generation. Then only it will be defined as green hydrogen. So what I told, one is a combination of solar, wind plus pumped hydro or battery reaching a 70% CUF, and the economics should work for that project. That's one way of dealing with it. Second way of looking at is on the electrolyzer technology side. That's where we also come in as OMIUM, where whether your electrolyzer has the ability to take the fluctuation of the solar and wind power, right? That is another way of looking at it. So our electrolyzer, not just OMIUMs, but any PEM technology has the ability to take the fluctuation very well. So you can design projects which can be directly linked between the green energy, solar and wind, without any storage, because storage adds cost, directly to the electrolyzer, and see that you produce hydrogen on that basis, and have the storage of hydrogen for taking care of the further derivative process. So this is the second way of dealing with it.
Yeah, thanks, Shaji, sir. I think Yeah, it looks really nice to hear that it's only like 60 to 70% utilization is possible and we cannot really go up. As a quick follow-up, if you could quickly help me also understand, if that happens, since we are not utilizing it for 30 to 40% of the time, how would that impact the actual cost of the green hydrogen? On one side, we talk about incentives, but then incentives are really not going to be suffice to really, it's not Inflation Reduction Act we have here. So it's much smaller, right? So how do you think about it, sir?
So, when we talk about green hydrogen cost, dollar per kg or rupees per kg, right? The major contributor of that is 70% the energy cost, which is solar or wind or combination of solar, wind and storage. 70% of green hydrogen cost is nothing but this energy cost. Another 10 to 15% is the efficiency of the electrolyzer, how efficiently it is converting solar energy into hydrogen. Third factor is the utilization factor. And fourth is the cost of electrolyzer. Right? Okay. So if you see, the major two components are the energy cost, solar energy or wind energy cost. So we should not bother about the third factor, which is utilization, much. First we should look into, can we produce more and more cheaper solar, which is tough today. Already it has seen the lowest point, and making it more lower will be difficult. But the kind of module pricing which we have seen in the last 6 months, it looks like we will be able to hit 1.5 rupees per unit of electricity. Okay. Right? And 70% CUF can be possible with 3 rupees per unit. And if you are able to reach 3 rupees per unit of renewable energy at a CUF of 70%, then you can produce hydrogen at around $3 per kg, which is very closer to the conventional hydrogen production cost. That is very good. Like 2.5 if you reach, then it's an inflection point and it will be only green hydrogen. But I see that it will happen probably towards 2030.
Okay. Thanks so much for the clarification, sir. So now I just wanted to change the gears and then move on to Jatin and asked about it. So, we talked about, Pawan sir has clearly mentioned about indigenized electrolyzer manufacturing. And there are in the previous discussion, when Milind sir also talking about the academia to industry, then or lab to fab, whatever the term we could use. It's in India, I think honestly, my feeling is that we just wanted to say that I want to become the way America operates and the way China operates right today, because they built their ecosystem very strongly over time. All of a sudden we came and said, make in India in 30 minutes. I think that's not going to happen. I think I wanted to be honestly realistic here. I work with a lot of companies, and you need 10 years, strong 10 years of commitment to build the ecosystem, build the mindset. On one side, we have an extremely fast developing technology. On the other side, technologies do change very, very quickly. On the other side, our ecosystem is not really ready to adapt to this. But then you're really serving a fantastic job. When I'm coming in here, you have a technology at TRL 3 or 4, whatever it is. I'm moving into the very high TRLs. Let's get into this electrolyzer business, Jatin. So what do you think, what are the electrolyzer options that are available in the new technology domain? Of course, if you look at the alkaline, the zero gap technology is one of the new things coming up. And there are people talking about seawater electrolyzers. What do you think the challenge that you see in the Indian academics, getting the technology from them and then taking it to the next level? It can be a failure project, that's okay. When you scale it up, you tend to fail. Not all the projects have to be successful. What are the problems you typically face? Or what are the expectations you have from Indian academics where you can meet those localization requirements like what Thermax is looking for example?
Thank you so much, Arvind. If you remember 2 years back when we had a meeting and we came up with the idea that let's have a pilot where we can have end-to-end generation from solar, wind. Now micro-nuclear is also coming up, which might come. Yeah. So very rightly said, I echo them. And the thing is that what problems I have faced with academia is, for example, if you want to heat a water, you will just use a base plate. But when it comes to real operation, you will require a thermic fluid unit, cooling unit, lot of things. So where the cost effectiveness and everything becomes impractical, that is where we come into picture and have a small pilot plant and allow you to have that operational optimization in terms of cost, in terms of technology. That is one. Second part is, for example, when you are designing a catalyst for CO2 absorption, there is a possibility you might go with 100% purity CO2 cylinders, which is not the reality when you come to chimney, where there will be a combination of SO2, CO2, many other components. That is where we have seen the technology from academia has failed. That is where again we come into picture, replicate the scenario, and we do that. Okay. Now when it comes to talk about electrolyzer, currently AEM, PEM and SOEC, which is coming up. But still, if you see, when it comes to cost effectiveness, no one is able to deliver, and still tremendous amount of research is required. For example, what I believe, if you are able to generate an electrolyzer which can directly use the seawater and provide you the hydrogen, that only you can be cost effective, because when it comes to electrolyzer, there is a life cycle, there is a possibility of poisoning of electrodes. So still that has to be understood at a pilot scale, and all this technology should be evaluated performance-wise. Then only I think we will be future ready, and I still believe it is very optimistic to have that 25 gigawatt of electrolyzer installed, because how the technology is evolving, there will be a drastic decrease in cost. So if you go with a bigger plant, the company which has installed initially will be at the, I think, non-profit.
Just as a quick connect question, Jatin. Typically, one of the fundamental problems we have is that continued funding. I think, irrespective of we accept it or not, I mean, we get money for doing the research, but not continued research on a given activity. If you take US government or European, Chinese, Japanese, South Korean, essentially Israel, the kind of funding that they have to bridge this gap, even for fundamental research, as well as for the research to push the technology. For example, we had an imprint program, and I'm sure I'll create enemies here by talking about it. It's been killed. Imprint was one of the successful scale-up programs where academics and industries work together to the conceptualized ideas can be pushed into the higher TRLs. Those are the things that were killed. How do you see Indian government or state governments or investors, or like we have a lot of CSR fundings available now, instead of pumping a CSR into planting trees, good. But I think this is a technology-driven world, and I think, so there are some estimates say we have 32,000 crore CSR potential every year in the country. You take like 5% of it, that's really good. If you take 10% of it, that's really good for a lot of climate-related activity, research. What do you think Indian government should, or industries should do in terms of funding this translational research?
See, let us start with first companies. So when it comes to companies...
Thanks for that order.
Yeah. So it's like economical viability. They are going to see how much value it has been created. For example, if you go to any venture capitalist also, he will ensure single penny spent.
Jatin, let's not go into the viability side at all. For example, now we are all convinced electrolyzer is going to be the biggest business, right? For example, like let's say in the electrolyzer system itself, there are a lot of research that can be done. How do you think they can fund? Why they are not funding it? No, 32,000 crore potential.
That's where I am coming economically viable. Economics and profit. When it comes to industry, it's simply making profit. Now government, absolutely correct. That's why I think I also pitched this thing to our Niti Aayog CEO, Amitabh Kant, and asked him that why, like Norway, if you go to Norway, we are one of the cheapest. We are serving oil and gas industry in a big way. You are knowing that, right? Yeah. So when we go to any like Equinor from Norway, even though we are providing the service at the 1/10 cost, they will pay higher and go to their institutes only, right? So there should be a mechanism where private sector should also be involved. Norway has a biggest mechanism, and that's why if you see, Norway and German technologies are coming up in a big way.
Is it because of government push that enable the industry academic collaboration?
Yes.
Okay.
Yes.
Okay. Great. Thanks, Jatin. I think, in fact, my fundamental belief is also the funding lag between, and also the expert lag. Although we find like in a department, let's say in any Indian institutes, ISERS, IISc, NIT, state institutes, there'll be only one expert or two experts in the whole institution for a subject. And my personal belief is that one or two experts never serve the needs. Like two, not sufficient. One electrolyzer expert across IITM might not really meet the entire country's requirement, right? I think Saji sir is picking up the mic. I think I'll let him answer that.
No, I just wanted to tell that, see, if entrepreneur spirit is there, if you believe in a technology or believe in an industry like green hydrogen, like I can cite my own company's leadership and promoters. We have pumped in around 50, $60 million, right? That's a huge money. Purely to see that how we can bring a PEM technology, which is very exotic NASA spacecraft technology to industry, right? For 3 years now, they have spent $60 million in research and development. And one of the lab is here in your campus.
Yes,
Next
thanks for
door in Seaving, we are in Deving here. Seaving, we have one lab is in Bangalore, and one lab is in US. And we have spent so much of money to see that we make a commercially operating, financially attractive technology which can help the world convert more and more green hydrogen. So it's matter of entrepreneur spirit. If you know and you are ready to bet, you have to put your money, and then there will be people who will put your money. So that first spirit should be there. Then only government or venture capitalist or PE will come in.
Sir, I totally agree. Entrepreneurship spirit should be there, but it's all about mindset. When it comes to Indian condition, mindset of Indian businessman is not in that scenario, whether if Adani or Ambani or anyone. For example, myself and Arvind are always discussing, I am telling you are not giving me any project. He's telling, no, I don't have funding. Now, when it comes to take money from a businessman, he will come and tell us, show us the demonstration. Show us the demonstration unit, then only we will discuss.
Correct.
So without demonstration unit,
Yes. So like if you see in green hydrogen now, government has come up with for steel industry. I think there is enough fund given to come out with new technology and idea to convert conventional steel into green steel. Right? Money is there. But yes, you have to convince with a concept that it's workable concept. And not just Ohmium, even Pawan is there from L&T, I am from L&T. When we started solar in L&T, I got money without any condition from my management to start the solar business, to show the concept, how it will work. 2009-10, there was no solar in the country in a big way. The money for 1 megawatt rooftop was given to me. So if such initiatives are taken, definitely it is possible that we can scale up a technology in the country.
Great. Okay.
I'll just add a
Before we
point.
go, we'll have a quick one from
You see, the way I see the hydrogen segment is today what solar was 15 years back at 16 rupees, 20 rupees tariff. And we have never believed that solar could be a 3 rupees a unit cost, but what it is today. So solar is in that 16, 20 rupees tariff situation what solar was 15 years back. And, there are many companies in India. L&T was one, Ohmium is another, there are many, Thermax is another, who believe that by localization and by continuous innovation, you cannot be fence sitters. If you are fence sitters, you will lose, India will miss the bus like it did for solar. So I think that realization fortunately has come in for the hydrogen sector. Government is incentivizing production, manufacturing, R&D. It's not enough, I agree. It's actually, it should be much more, but it is still a step in the right direction. Policies have started coming. Bankings of the power, the renewable energy, there are a lot of incentives given. Certain states are offering as high as 30% capex subsidy, on green hydrogen projects. So I think India has taken the step in the right direction. And I believe that, today, for example, if you look at alkaline electrolyzers, installed cost is about $1,000 or $1,200 per kilowatt. I firmly believe that by 2030, these costs would be about $250 or $300.
Oh, that's excellent. Okay.
A PEM technology would probably be around $400. A solid oxide technology, we are talking of solid oxide, which was $4,000 in 2020. Today it is $2,000. And I have had a lot of meetings in Europe with some of the leading companies. We cannot name them, but the feeling I'm getting is that solid oxide will go to around $300, $400 by 2030. But if India and Indian companies sit on the fence I think Sujoy made that statement that we are increasing the forex is still getting drained out. The same thing will happen for the hydrogen segment if we don't take action. So I think, but I'm seeing it different from solar. There is a lot of activity in India. L&T is setting up a 1 gigawatt plant based on the fact that demand will come in the subsequent years. Omium has set up a 500 megawatt plant and they are further expanding it. There are about Greenco and John Cockrell have a joint venture and they are setting up a 1 gigawatt. So I think what did not happen in solar is happening in hydrogen segment. More and more incentives are definitely required. There are demand mandate which is still not come in, I think, which the government is still considering. So I'm very positive about the way things are going, and I do see India as a hub of a manufacturing of electrolyzers and the related component by 2030.
Yeah, thanks, Pawan sir. I mean, it's again, I find the optimism, and I'm really happy to hear all those like fantastic initiatives back again re-emphasized from you. Still, I believe that on the R&D side, push has to be a lot more. On one side, expectations is more like you still said European companies. They are manufacturing it and we are getting the technology. Anyways, I think we can discuss that one offline. I think Indian R&D ecosystem need to grow much longer is what I believe, definitely. But before, I think we'll pass this topic during the break, but then I would like to go to Anand and ask him something about very important thing about fuel cells. Anand has been in the fuel cell company and he's one of the strong technocrats, as I've mentioned before. Anand, I would like to understand from you, from the utilization of hydrogen side, we always talk about either should we use fuel cell for powering the vehicle application, I mean, to the mobility sector, or to the power sector, because those are the two sectors where definitely fuel cells can go. Our interactions with industries, it can be a larger automobile OEM, or it can be a smaller two-wheeler OEM. They always say that hydrogen to power is quite expensive compared to the batteries. So, there I find a downside. Of course, most of us would agree that heavy vehicle segment might still take up. Now, on the other side, like let's say, if you want to go to the power sector, so people from GE, they have gas turbines. We have gas turbine experts sitting here. Burning hydrogen in the existing gas turbines by small retrofittings can give power at more cost-effective way than the fuel cells. This ambiguity still remains. Honestly, this is a question among many of us. I'm sure many of them have the question also. I would like to you to help us with what is the actual clarity, what is actually happening with the fuel cells, what is the reality of fuel cells?
Thank you for the question. So before answering it, hydrogen is very valuable as a chemical molecule more than as a fuel. In the present context. So that's what I would like to make it clear because it has very nice applications as a molecule already in the industry. But if you now say I would like to use hydrogen as an energy carrier, then yes, the question becomes relevant. So one is to use it as an automotive fuel or probably use it for the stationary power generation application. So as rightly put, the kind of customers we get in Europe and also in India are for the heavier use case where the decarbonization is very difficult. So one of them would be the marine industry and the second would be the very large containers, transporting your food and goods across intercities. But for the two-wheelers, the small cars and even SUVs, the cost of the fuel cells, in kilowatt per dollar would not make sense to go, if the vehicle becomes too small. It's only relevant if your vehicle size is, big.
Yeah, but so there's one place, sorry for the interruption, Anand. So one place where I've read is the pace at which the battery is growing. Of course, we do agree for heavy vehicles. I mean, I personally believe that heavy vehicles is going to be with hydrogen. But then I was reading a paper on Nature Energy recently. They have kind of made a projection. Of course, the fuel cell powered by hydrogen is growing in one direction. But then the pace at which the lithium-ion battery is growing is much, much faster than that. And then they say it has no technical merit. It is just by the history. If you go by the merit, like the silicon germanium competition, and I'm sure Melissa can also bring in other semiconductors. Silicon One, right? Or other semiconductors which try to fight with silicon. So, what do you think about the competition that's between the fuel cell or hydrogen powered systems to the batteries, considering the state at which it's growing or rate at which it's growing?
So the traditional, dialogue what a fuel cell power system or a hydrogen fuel cell power system guy would give you is that the time to refuel a very large truck can happen in less than 5 minutes. That's how all the refueling stations are designed. But if you want to push in the same amount of kilowatt hours into that vehicle, if it were all battery, it would take at least 90 minutes or bigger. So that's one disadvantage of the battery, which the hydrogen guy tries to, play upon. And the other point would be the gravimetric energy density in terms of kilowatt hour per kg. It becomes to the disadvantage of battery when you try to, for example, move a ship for 30 days on a battery. It's not really economical. But if you would may probably run a submarine or a ship on hydrogen, the amount of kgs you need to carry for the same kilowatt hours on board, a hydrogen solution would be more apt. So in that sense, the amount of dead weight you carry for the same kilowatt hour, hydrogen would win. And the amount of time you take to push those many kilowatt hours into that, that vehicle.
Yeah,
Hydrogen.
Anand, this is really, thanks for enlightening us that there is a complete segment, not just like the ones running on the road, but the running on the water is much more important than the ones running on the road. That's really great. And I feel like now IIT Madras Department of Ocean Engineering and Naval Architecture has to really come and talk to you and try to convert their supposedly boat research or submarine research into hydrogen powered ones, supposedly they are powered by.
In fact, most of the orders which we get in Switzerland are marine industry for portable applications. The rest are all for renewable microgrid, where they are trying to go off grid and balance the grid. Like some of the panelists rightly pointed out, there's a lot of solar and wind which is coming into the grid, which is highly intermittent. So there you could cycle an electrolyzer, a battery, with a fuel cell and still supply, for example, a fixed 50 kilowatt hour to the grid.
Okay. Great. Thanks, Anand. What I'm going to do is I'm going to ask a very quick question, just we can answer in 30 seconds to 1 minute, and then I would like our panelists to give the final thoughts to our guest audience here. So one is on the technology development side. One other very disturbing thing that I've seen in the news is that many of the electrolyzers that went into the usage or into the field really stopped working, and they were put to idle state for longer time. This is true for any technology. When it's evolving, obviously it will happen. But I think in Indian context, it might be fairly new because we always been at the receiving end of the mature technology, not a technology at a very early stage. Pawan sir clearly pointed out, India really stepped onto this technology very early. And now, how do you see the ecosystem in India to accept these kind of failures? I think I'll start with Pawan sir, and then I'll come back to you and slightly twist the question.
Yeah, actually that's right. I will not deny that what you said, because there have been some issues, not only in China, but even on some European and American electrolyzers in the last 1 year. There have been a few recalls, and there have been some companies have even reported something like 25 to 30% rejections at the testing stage of electrolyzers. And there was recently an article about the problems which the electrolyzers in China are having about the going down to lower loads. So I think these are all part of a growing up phase, because if you look at it, suddenly in the last 2 years these big size electrolyzers have actually been introduced, and I think it's but natural that some of these electrolyzers on the field will have some problems. But on the China side, the problems are now getting identified to not so good materials being used in the construction of these electrolyzers, and that's why the Chinese electrolyzers are relatively cheap. I think as far as I don't think that is cause of any much concern, because I'm even aware that certain good companies have kind of run the electrolyzers for about 8,000 or 15,000 hours before they're introduced to the market. But some companies have, in the rush of things and trying to accelerate development, have introduced these products before extensive testing which has been done at their end. I do not think it's a cause of concern, because if you look at the manufacturers of electrolyzers, they are, companies like Cummins and Siemens and the big names are also into electrolyzers, and there are a few startups which are into the electrolyzer manufacturing. In fact, about 80% of companies are startups today, who are getting. They used to be startups, but with this, hydrogen getting into a big phase, these startups have now, these technology companies who were startups are now trying to convert themselves into manufacturers. So that is one reason why you're finding this problem. So in fact, one of the decisions which we took at L&T when I was there was that we will actually test the electrolyzer for 8,000 hours before we introduce into the market. So right now, as we speak, and since I was part of that, there is an electrolyzer which is getting tested, which is running 24/7 at one of the L&T sites. It's been running for 6 months. It will probably run for another 6 months, and the product will be introduced after that. So I think we need to be careful. Also, I think there is a lack of standards in the Indian industry. I was part of that committee which was with MNRE and CII, wherein certain shortfalls of the IS standards for manufacturing and for quality checks and all those shortcomings were actually brought out in that committee, and now those are getting implemented. So I think it's a growing phase, but probably the Indian customers need to be aware of the fact that, if they are sourcing an electrolyzer, has it been tested enough? Does it meet the certain critical standards? For example, electrolyzers in China don't meet certain worldwide and European and American ASME standards. They don't meet. They only meet certain Chinese standards. So I think you need to be an educated customer, and you need to buy the right kind of proven electrolyzers and the associated components to make sure that you don't get into problems once you have done that.
Great. So thanks for re-emphasizing the confidence in the technology. I think this is really nice, and also like trying to say to the customers like what's actually you can expect. Failures are normal. Sir, since Omnium is also like kind of manufacturer of electrolyzers, could you please summarize very quickly on that? Like what do you think?
So no doubt about the technology, because this technology is operational not for a few months or a year, right? Alkaline has been there for hundreds of years. PEM has been in operation for maybe 30, 40, 50 years, right? And spacecrafts, submarines, steel plants are depending on alkaline and PEM technologies. So no doubt about it. Technology is proven, technology is stable. Now what issues we are facing in the world today is because of the scale up. Now you suddenly want hydrogen in every application, right? You need a lot of electrolyzer. You need to immediately start manufacturing. So when you do that, that kind of scale up issues will be there. But technology is proven and stable, right?
Okay.
Is summarizing the technology part of it. Now, as far as Omnium is concerned, like you told, in the last 3 years, we have developed the technology and brought it to the market. Next Sunday in Delhi, we are going to do a hydrogen cooking event, where from our electrolyzer, which is running there in Delhi, we are going to tap hydrogen, cook, actually like pongal or some dish, and show to the world.
Are we invited, sir?
We are working with a customer. We have to get their permission. If they allow, we'll
Just
do
kidding.
that.
Okay.
So that is the only way to demonstrate that machines are working.
Yeah.
Pongal in Delhi, I thought it should be butter chicken or something.
Oh, of course. In winter, there could be many other options.
Okay. Yeah, I think let me skip this question both to Anand and Jatin because of the time limitation. But I wanted like we discussed quite a lot of things. By the way, this session talks about aluminum, steel, and all those things. But then I felt like there is a pitching problem first at generation of hydrogen before getting utilized it, right? And that's why I've kind of really emphasized and focused this whole session around this generation side itself. Because unless we solve this, nothing else can happen. As simple as that, right? Now, I would like to request all panel members to. We have like 3 minutes, 30 seconds to re-emphasize. I'll start with you, Jatin, on what exactly we have to do in order to get the hydrogen transition into the reality very quickly.
So, what rightly said by Sachin is that technology is ready. However, I think that hydrogen seems to be very promising, only competitor to crude oil and gas industry. Another thing is the other components of the operational part. For example, membranes and many other components which are the part of the ecosystem. I think we should have that also ready, manufactured in India, so that we are not dependent on other countries.
Thanks. Pawan sir? A question about your last and final thoughts on how to enable this green hydrogen transition quickly.
You see, the way I think of it, that hydrogen is often said to be the Swiss knife for decarbonization, and I don't agree to that. I think it has
Thanks
its
for it,
limited applications. It's one of the ways to decarbonize. It's not the only way to decarbonize. We have to find the right applications. And I think, as one of my panel members said, we should not burn hydrogen for generating power, for example. Power to X, wherein we convert hydrogen into ethanol, methanol, e-fuels, use it for the steel industry, use it for chemical industry, use it for the ammonia industry. I think those are some niche applications. So for example, I saw that there is a big thing of trying to push hydrogen into everything, which will not happen. So we need to have, for example, steel cannot be decarbonized without hydrogen. Refineries cannot be decarbonized without fertilizers, cannot. So there are certain segments which cannot be decarbonized, and we should focus into that. We should not rush into everything. So in my view, the Indian industry, the government of India, the ministry also needs to, focus on certain sectors rather than trying to say it's a cure for all. And that, I think, will be very important if we have to have a reasonable success of hydrogen by 2030.
Yeah. Thanks for this. In one meeting, I've also said that people are saying that hydrogen can also cure cancer. I think that's the only thing that they didn't say. Other than that, they said that it can do everything. And you brought that point one more time. Shajit sir, if you'd like to quickly summarize.
Yeah, quickly. So 2 points for me, how we should look at it. Number one is hydrogen is expensive today. There is a gap. Like, for example, $2.5 is the conventional hydrogen, whereas green hydrogen is anywhere between $4 to $7. So by the time we bring down green hydrogen from $4 or $7 to $2, there will be intervention and support needed from the government. So that is very much required for enabling the industry. Otherwise, it will be a slow process. It will happen for sure, but it will be slow. So this is part one. Part two is, like Jatin told that earlier, Pawan told that there is going to be electrolyzer made in India. No doubt about it. I have 200% confidence that there will be 25 gigawatt of electrolyzer manufacturing in India by 2030. There's no doubt about it. Now, like Jatin told, that the other ecosystem to support production has to be there. And only entrepreneurships, including IITians and many of the young industry sitting here, has to work on those components to supply to these large electrolyzer suppliers like L&T or Ohmium, etc. And it is possible. Today, Ohmium in 3 years has created 85% indigenized component. We don't import anything, more than 10% maybe. 90% is Indian suppliers are giving us, which is, there is a possibility. So these are the two ways to take it forward.
Great. Thanks, Shajit sir. Anand, I think I want you to give us the confidence that there is fuel cell and there is a life for it.
Yeah, I think all the panelists have put it really well. I won't repeat what they've already told, but Essentially, in my opinion, technology is basically something to do with applied physics and applied mathematics. So, if to all the youngsters who are sitting here, I would strongly suggest is get the clarity well on these topics. There is fluid. For example, if it's a fuel cell power system, there is heat transfer, fluid flow, thermodynamics, heat transport phenomena, and electrochemistry. So clarity on these, and then how well you articulate it using tools to actually build the products. That is something I see lacking. Because the last 3 years I have been in Switzerland, and the 3 years before I have been in China. So if I see the Indian audience, we are equally intelligent and equally hardworking, but somewhere that synergy is missing.
There is no ML and AI in it, Anand. That's why.
So it is my wish, that someday, and it's coming. It's just the focus. Everything is not money. Everything is not approvals from government or so. It's if we have the the rich clarity in these technology, science, the engineering is there. It's going to make it happen. Yeah. Thank you.
Anand, I think you really filled in the academic gap. Thanks for really emphasizing the thoughts that I really wanted to say. I'm sitting in this side, so I cannot share that. So thanks for really sharing that. So there are like a really great bunch of thoughts. In fact, honestly, these were the questions I've had, like personally to myself, and not as a panel discussion that I want to ask these questions. But I thought since the experts are sitting here, I thought I'm sure many of you might also be having a similar question. So I put them up to them, and we got really fantastic answers from them. Creating a supply chain, creating entrepreneurships. And kind of really, hydrogen is not a solution for everything, but it's going to do certain things. And Anand's re-emphasis on engineering fundamentals, and I'll add one more thing, that it's never just about ML and AI. I think especially for IITians, there are a lot more things in engineering, and there is a life in everything. And with that strong discussions, I strongly believe India is going to be one of the strongest leaders in the hydrogen segment, with the fantastic leaders like whom we have on the dais. India can make a big show and become one of the top 2 or 3 countries in the world in the hydrogen segment. And as a side note, so at IIT Madras, we are establishing India's largest hydrogen hub, and which Omnium is a part of already, and EH Fuels as well. And there's something big in cooking. Please expect some good news in the Global Investors Meet on 7th of January. With that, I'd like to thank all my panel members, and thank you so much everyone for listening to us in the afternoon, after a heavy lunch. Thank you.